What if I told you that Earth, billions of years ago, wasn't the green and blue marvel we know today? Instead, it shimmered in shades of violet, a world both alien and familiar. Could this forgotten chapter of Earth's history hold clues to life's origins, not just here, but across the cosmos? Let's dive into the purple Earth hypothesis and uncover the strange and colorful mystery of our ancient planet. To understand why Earth might have been purple, we need to go back roughly 2 to 3 billion years. This was an era known as the Archean Eon, a time when life was in its infancy. Back then, the Earth was a harsh and alien world. The atmosphere was mostly carbon dioxide, methane, and nitrogen. Oxygen, the gas we depend on, was practically non-existent. The sun was also fainter, emitting about 70% of the energy it does today. Yet, somehow, primitive microorganisms managed to thrive under these conditions. How? Scientists believe these organisms developed a unique way to capture sunlight. Instead of chlorophyll, which gives modern plants and algae their green color, these ancient microbes might have used retinal, a light-absorbing molecule that reflects purple and red hues. Retinal, which is still found in some microorganisms today, is incredibly efficient at capturing green light, the most abundant wavelength of sunlight. Retinal is a pigment still used by some microbes, like halobacteria, found in extremely salty environments. It powers a process called phototrophy, where light energy is converted into usable energy. Unlike photosynthesis, this process doesn't release oxygen. Why does this matter? Because retinal's efficiency with green light would have given early microbes a huge evolutionary advantage on a young Earth. Imagine a planet where shallow seas and land masses shimmered in violet hues under a dim, reddish sun. Could this have been Earth's original biosphere? So, what changed? About 2.4 billion years ago, Earth experienced the Great Oxidation Event, a major turning point in the planet's history. Cyanobacteria, organisms that use chlorophyll for photosynthesis, began producing oxygen as a byproduct. Over time, oxygen levels increased dramatically, transforming the planet's atmosphere and ecosystems. This transition may have driven retinal-based organisms to the edges of survival. As oxygen became more abundant, chlorophyll-based photosynthesis became the dominant strategy. Chlorophyll is better at converting sunlight into energy under high oxygen conditions, gradually outcompeting the retinal users. Here's where things get even more fascinating. If retinal was once the dominant pigment on Earth, could it still be the primary pigment on other planets? Exoplanets orbiting stars dimmer than our Sun, like red dwarfs, might favor retinal-based life over chlorophyll-based life. Retinal's ability to absorb green light makes it ideal for harnessing energy in environments with lower light levels. This means alien worlds covered in purple vegetation or microbial mats might not be as far-fetched as they sound. Interestingly, traces of this violet era may still exist. Retinal-based microorganisms, like halobacteria, survive in extreme environments today, such as salt flats, brine pools, and hypersaline lakes. Could these be the last remnants of a world that once shimmered in purple? Studying these organisms could help us understand the resilience of life in extreme conditions and provide clues to detecting similar life forms on other planets or moons, such as Europa or Enceladus. A purple Earth would have had unique climate dynamics. The faint young sun provided less heat, but the retinal-rich surface might have absorbed sunlight differently, affecting the planet's energy balance. This could have created a warmer climate than expected, allowing liquid water to persist despite a weaker sun. Could this have delayed or accelerated the emergence of complex life? Scientists are still debating. If Earth really was purple, it reshapes how we think about life's origins and evolution. Could retinal-based life re-emerge in extreme environments if Earth's conditions were to change again? And more importantly, Could this forgotten chapter of Earth's history offer a roadmap for finding life in the universe? If retinal-based organisms were once so successful here, it's possible they could be thriving on other worlds right now, waiting for us to discover them. The Purple Earth hypothesis is more than just a colorful idea. It's a reminder of how much we still don't know about our own planet's history. From the way life adapts to extreme conditions to the search for alien ecosystems, this theory opens a new window into understanding life as a universal phenomenon. So, was Earth truly purple? The evidence is still building, but one thing is certain: the deeper we look into the past, the more extraordinary the story of life becomes. What do you think? Could our planet really have been bathed in violet hues billions of years ago? Let me know your thoughts in the comments, and if you enjoyed this exploration, don't forget to like, share, and subscribe for more cosmic mysteries.